Oh, I had a video chat last night. There's a couple people I'm mentoring in some programming language stuff. This guy's from New Mexico, and he was complaining that he's like, "Oh yeah, it's been cold. It's like 50 degrees." He was complaining about 50 degrees. It's like, do you know in Wisconsin when it's 50 degrees, people stop wearing pants? All right, how did the quiz go? It went. You what? Really? This shouldn't have been that bad.
It's always easier when you have a computer.
I don't think this would be very hard to write without a computer.
Well, it's always easier.
You think?
Yeah, because it tells you where you screw up.
Well, I mean, but I'm gonna look past that on the quizzes. All right, so we'll go to our linked list. Okay, so for what did I name the print odds? Okay, so we're gonna have a method. What's the return type going to be? Void, because we're not actually returning anything. We're just displaying stuff. So return type is going to be void. The name of it is going to be print odds. What parameters does it need to work? Nothing. Everything it needs to do its job is self-contained inside of linked list or in the node class. All right. So we're going to say node cur node is equal to head. So we'll have something point to the front of the list. While cur node is not equal to null. So as long as it's pointing to a real node. If cur node dot get payload mod 2 is equal to 1. This says if this number is an odd number. You could also say if it's not equal to 0. This says that when I divide this number by 2, I get a remainder of 1. When you divide something by 2, the possible remainders are 0 and 1. So this says if it's an odd number, then what are we going to do? We're going to display it. Regardless of whether I displayed it or not, we're going to set cur node equal to his own next node to traverse down the list. Okay, so cur node starts at the beginning of the list, so we don't have to change head. As long as cur node's currently pointing to something real, we'll look at the payload. If it's odd, print it. Otherwise, well, regardless whether we printed it or not, we'll move on to the next node. Spin back up, check to make sure cur node currently points to something real. So keep going as long as cur node is pointing to a real node on the list. So that is a reasonable solution. Questions about that? So fair, was that hard?
Oh no, it was actually pretty simple.
Now when you see it, do you understand it? Yeah. Okay. Just you couldn't make the jump between reading the question and writing it. Once you see it, you see how it solves the problem.
I couldn't make the jump from void to print odds.
Okay, why not? Why?
That part I got. The only part that I got is I know I messed up on was cur node dot get payload.
The only part I messed up on is everything in here. And I think I screwed this part up. And I don't remember what I wrote in here. All right, so all of you should be able to do this at this point. Now, writing it off the top of your head, error-free, that might be a little bit more hit and miss. So when I look at these quizzes, if you miss a semicolon, I don't necessarily care. If in here you say cur node dot get next node is not equal to null, but all the rest of your logic looks like you pretty much know what you're doing, that's something that I would understand that you would figure out after you run it once or twice. So I'm looking for competence. Did you write something that looks like functional code or functional-ish code? Make sense? So this guy should print odds. Let's see what our current list looks like. So we have a 3, 7, a 4, a 2, a -4. Okay. So now we can say ll dot print odds. And there's our odds, 3 and 7.
So I had a problem after uploading to GitHub.
Are you lying?
No, it won't run anymore. It says there's no main type, but there clearly is.
No main type. Well, it's complaining about fraction.
The fraction is in the other.
Well, I get that,
other project.
but that's what it's complaining about. So if you, let's try running with that. Does not contain a main type. Man, you do weird stuff with it. You have all the stuff open at once? Yeah, where it's complaining about is up here in your CSC300 thing, the fraction. It says you're missing a semicolon on that line, which makes sense, but the real question is why is that complaining about that if you're not in that project?
Yeah.
That. Oh, I see. All your code is not in your source directory.
Did it get rid of it?
No, it's like it's moved below. It's in the project, but not in source.
That's weird.
So here, let's move it back to source. Now we have a default package. It's complaining about linked list. Cur node.get next node is a method, so you had an error in there. Now it should run. So, yeah, I don't know. It's something you were doing, moved all your .java files outside of the source directory, which is where Eclipse tries to run it from, and put it underneath the project folder, but I don't know how you got it into that state, but that was the problem. All right. So right now our linked list has, well, it has this ability to print odds. We're going to go ahead and remove that because that doesn't make a whole lot of sense for stuff, but everybody have that written down if you want it. Scream if you, all right, it's gone. All right, so what abilities do we have? We can create a linked list. We can get something from a specific index in the list. We can get the count of the list. We can display the list. We can add at a specific index. We can add to the front of the list. We can add at the end of the list. The abilities we don't currently have, though, is removing stuff from the list, right? So we need to make counterpart methods for each of our add methods. So we need to be able to remove from the front. We need to be able to remove from the end. We need to be able to remove at a specific index. I bet you can't guess which one is your homework assignment. So I'm going to rate some of the easy ones. So we need to have a method, probably going to return a node, although you could make the argument, actually, we're going to have it return an int instead of a node. Most people who want to remove something from a list are probably going to want the payload that you removed as opposed to the actual node. Because a person utilizing the list doesn't care about the container the value is in. Okay, that node object just had something to do with how the list worked. When you're removing something from the list, you probably just want the value you just removed. All right, so we're going to return that as an int. And we're going to call this guy remove front. All right, remove front's going to take no parameters. And what this guy's going to do is he's going to remove the node from the very front of the list, leaving the rest of the list intact, and ultimately return the integer that was removed. So let's go back to our pictures. Let's see, well, this is good enough. All right, so this is my current list. Head points to the front of the list right here, and then the list goes from 5 to 4 to 1 to 2 to 6 to 3. That's what this current list does. If I want to remove from the front, I'm removing the element that head currently points to. Make sense? So graphically, what do I need to do? Well, I can't just set head equal to this guy, because now I've lost my connection to this guy. I no longer have a pointer. Does that make sense? So if I immediately just set head to head's next node, pointing it at bucket 1 of our list, the second element in the list, I've left nothing pointing to the beginning of the list, so I can no longer return this value. So we probably need to use our cur node, or a similar type variable, and have it point to where head points to, so we have access to that. Then we can make head point to the next place. Then we can set cur node's next node equal to null. That will officially detach it from the list. Then we can return this guy's payload. That makes sense, those steps? So remove front is going to say node cur node is equal to head. So make cur node point to the same place head points to. Then we can say head is equal to head dot get next node, which very well might be null if we had a 1 list. Okay, and we'll look at how that might go down here in a few minutes. Then we can say cur node dot set next node to null. That detaches it from the list. And that's somewhat important. From a Java perspective, let's just do the order of operations here. Line number 1 in our code says create cur node, set it equal to head. That's this first line right here. And what that's doing is this right here. It's creating this new variable, well, I called it cur out here, but cur node, and making it point to the same place that head points to. Okay? Next, it says set head equal to its own next node. Make sense? So now head points to its own next node. So our third line that I have written right now is set cur node's next node equal to null, which does this. Here's cur node, who has a next node variable, and we're setting that equal to null. Is that necessary? What would happen if I left it pointing here? Wouldn't be able to get to what? So this guy? Okay. So you're saying he would not be garbage collected because, well, why would he not be garbage collected? So he's still attached here? Okay. Now, when our method ends, when remove front ends, what happens to this variable cur? It was a local variable associated with our method, right? Okay. But this node still is there, somewhere out in memory, right? So at the end of our method, that happens. How many things currently point to this node right here? 0. So when a pointer count for an object goes down to 0, it will be garbage collected, which means that Java will come through with a dump truck and get rid of any places that are not reachable in memory. And this is one of those guys. Okay, so in this example right here, he would be garbage collected. So since he would be garbage collected, so would all of his stuff that goes along with him, like that. So did we actually need to detach it? Probably not. Didn't need to detach it. Is it good programming practice to explicitly disconnect stuff when it makes sense? I think probably. So my opinion is you should disconnect this so that at the end of it you have this logic that says, here is a node floating out in space. It's not reachable and you can't get anywhere from it either. Clearly this guy will be garbage collected. Make sense? Okay, so I like doing the disconnect, even though it's not necessary for everything to work out. Because when this guy ends up being garbage collected, this goes away, which then makes the pointer counter for this node go from 2 down to 1. Because right now there's 2 things that point at him. All right, so cur node is equal to the front, set head equal to his own next node, cur node set his next node to null, and ultimately we are going to return cur node.getPayload. Now, what if head was null in this case? So we have the empty list. This very first line here is going to set cur node equal to head. So we're creating a new node variable called cur node and initializing it with null. Fair enough. So no errors on this line. Possibly a waste of time, but no errors. The very next thing we're going to do is we're going to set head equal to head's next node. We're going to get an error on that line. What's the error? Null pointer exception. Why? Because head is equal to null. There is not a node there. Head does not point to a node. And if there's no node, there's no getNextNode method, which came from our node class. We don't get one of those because we're talking to nothing. We're talking to the wall. Okay? So, in the event that we are dealing with the empty list, this would be illegal code. You cannot ask a null value to start calling methods. There's nothing there, nothing to call. Okay, so we'd get a null pointer exception here. We'd also get a null pointer exception there. We'd never reach that line, but same argument. Cur node is equal to null because he pointed to the same place head pointed to. And in the empty list, that means they're both null. So now I'm trying to call nothing's next node method. And finally, we're trying to call nothing's get payload. There's no node. I promise you there's no payload. All right. So we only want to do this stuff in the event that there is a first node to remove. If there's not a first node, what should we do? This gets back to what we were talking about from 2 classes ago. where we made a decision to add an index. Anything less than 0, less than or equal to 0, we added at the front. Anything greater than or equal to count, we added to the end, instead of holding them to legal values. So we'll just use our exception example here with remove front. What should we return if somebody calls remove front on the empty list? This method says we have to return an int. Does it make sense to return an int in the event that we have an empty list and are trying to remove the front of it? Just in real life. Okay, so if you have a shoebox, and inside the shoebox it's like lottery ping pong balls. Okay, and you're going to reach in the darkness and pull out a ping pong ball that has a number on it. All right, but in this case, the shoebox is empty. When you reach in and you attempt to pull out a ping pong ball, which is what you expect to pull out, right? Just like we're expecting this guy to return an int. When you take your hand out, what are you going to have? Nothing. You won't have like the generic ping pong ball that doesn't have anything on it. There was nothing in that box. Couldn't pull anything out. So what are we going to do? Are we actually going to pull our hand out and say, here, this is what I found? Or are we going to look up and say, this box is empty? We're going to have some sort of feedback like, okay, look, is this some kind of joke? I reached in to get a ping pong ball. There was nothing in there. Box is empty, just so you know. Okay? So we need to have a way of having that dialogue. And that in Java, that's something called an exception. And that's something we have not covered yet, right? We talked about it 2 classes ago that I was going to cover it, but last class we talked about GitHub. Okay? So let's talk about exceptions. Okay, exceptions. These are built-in error handling objects that allow programs to catch and potentially respond to an error instead of just crashing. Okay, now let's see one of these in, let's see an example of using a built-in exception. So I'm going to go back out to main here. And we'll just go ahead and, here, I'll just comment out all of our list stuff for right now. There's our practice for our multi-line comment. Slash asterisk slash at the end. So this allows you to comment out big blocks of code. And what I'm going to do is I'm going to say string s is equal to hello. All right. And then I'm going to say system.out.println s plus world. All right, so what should the output of this program be? Hello world. Why? What's the plus sign here? It's concatenation operator. Okay, and it knows it's the concatenation operator because at least one of the 2 sides is a string. So it knows to treat that as the concatenation operator. Make sense? So this will be hello world. No surprise there. But now what if I wanted to add a 1? What's the output now going to be? It's the literal number 1, not the string 1. Not a trick question. I just said as long as one of the sides is a string, the plus sign is treated as the concatenation operator. So
Types it on.
just so it'll be hello 1, right? So this will print out hello 1. No harm, no foul. Okay, but you know what? I really, really want to do math here. Therefore, I need to make S a number. Now what will print out?
5-1.
5, 1. Okay, not 6. Still treated as a string, correct? Well, so what can I do? Well, I can say integer dot parseInt S, passing it the string representation of number 5. What will that boil down to right there? It'll boil down to the integer 5. Okay, so integer.parseInt, that method allows us to convert a string representation of a number into an actual number. So now we will get 6 printed out here. Now it treats it as the addition sign because this is an int and this is an int. Make sense? Okay, no harm, no foul. I'm going to change this back to hello. Now what's going to happen? When I try to change the word hello into its integer equivalent, what do you expect the result to be? We're back to our little shoebox example. Some kind of error, right? Okay, if I give you a steel block, I told you to go ahead and mix that up with some sugar. You know, put it in water, just mix it all together with sugar. What would we expect the result to be? Some water with sugar dissolved in it and a steel block sitting in the water, right? Okay, steel block doesn't mix up with any of that stuff unless you get it real hot. Okay, so that would be something that wouldn't make sense to us. Okay, if somebody said, I want you to mix this steel block up with some water and sugar, you just look at them like they were crazy. Right? Like, okay. So we need to be able to handle this. So I'm going to go ahead and run this. We're going to get a number format exception. It's computing. Isn't it computing? Maybe I didn't hit it. Well, I just saw it doing Git stuff down here. Which is funny because I actually deleted the Git thing. I hated the Git thing for Eclipse. Did anybody have any luck with that?
Yeah.
And it worked fine in the end?
Yeah.
It just kept. I have a lot of projects and it just made everything super sluggish. So I took it out, but apparently I didn't take it out good enough. I promise you this throws an exception. See, the funny thing is, it says it's computing the Git status when I definitely deleted that thing. In fact, not only did I delete it, I took Eclipse off my computer, re-downloaded it, put it back on, still there. Change this back.
Wouldn't it be in the Eclipse folder anyway?
Say this again?
Did you delete your entire Eclipse?
Yeah. No, I mean, I deleted the Eclipse folder from my computer and re-downloaded Eclipse from the... All right, so there's our 6. Let's change this back to hello. Man, do we need like to bring our priest in here or something? Do an exorcism on Eclipse. If I put in a real number, it's like whenever there's an exception.
Wait, you weren't ever printing anything though, so it wasn't.
Yeah, no, I was.
No, you had it commented out a minute ago.
Yeah, a minute ago, but before that I didn't. So this should be doing it, right? And you get a number format exception, right?
Yeah.
Give me a moment. All right, I got to do something here. This will actually be a fun little, not an experiment as much as okay. I wanted to run a very dangerous Unix command with the expectation of getting rid of all the .git folders. Okay, so I'm in workspace. Let's go back one. Okay, I'm in my Eclipse workspace. I'm going to do rm versus .-rf .git. That's the name of the folder, right? That's the name of the Git folder. Okay, so this should recursively go through everything inside the Eclipse workspace, removing all .gits from everything in there. Hopefully that will then remove all remnants of Git from those projects and convince Eclipse that Git is no longer part of its thing. All right. I still have folders, good.
Why does it say Melanie's iPhone?
It's like a thing. It's and sometimes it's not always Melanie's iPhone. I think it has something to do with Apple's their Bonjour networking. It picks up host names from other people's computers on the network and just says that you're that. It's done it for years, and not just in Yosemite, older versions as well. All right, so let's give this a college try. It's computing Git status. But there is no Gits. There is no Gits. Dang it. Dropbox awesome fat master. Oh, I wonder, is there a at the top level?
Should we download it all from the Dropbox then?
I wonder if at some point let's just run that command here at the top level. Because really, it shouldn't even know about Git. I literally uninstalled the packages and then deleted Eclipse. Re-downloaded a fresh version of Eclipse.
Doesn't Eclipse like have a built into it because it was just installed on that?
I don't see it. It didn't do it.
It's not computing the get status anymore.
I need an old priest and a young priest. Is that from, what movie is that from? Ah, I closed the console. Okay. All right. Everybody relax.
That's what it was the whole time.
But why isn't the console popping up on its own?
Probably because it's an error.
Yeah, but it should, I mean, it still should show up. Yeah, see the, well, no, hold on. What does this do? I don't want that. Close that console. What have I done? I've destroyed a perfectly good copy of Eclipse. All right, so now let's kill it. I'm just going to reopen these files. Eclipse needs a
So there is a, if you go under preferences, under run/debug, under console, there's a little checkbox that says show when program writes to standard error. Under console. And then put it up. There you go.
Oh. So, okay, hold on. So as this was written, if I would have said system.out.println blah, just whatever, that. Now it'll print out because it's going to be standard output,
Yeah.
and then standard error will show up on there as well. I get it. That's stupid.
It's a very specific thing to go.
Shouldn't that be checked by default?
It is on ours. Yeah.
Oh, really?
That's what happens when you root Git. It's like the final command.
It's like a final command. Screw with this guy. So in any case, that would be one of those rare examples where typically when students come to me and say, well, my Eclipse is broken, and I say, it's got to be user error. This was an example of when Eclipse was not doing what I expected it to do, and I knew it wasn't my code. Usually it is your code. So just keep that in mind. All right, so we get this number format exception. Well, this probably, well, in this case, this isn't really what we'd like to have, but it's better than it spitting out like the number -1 or something like that. Because certainly, -1 could be the legitimate result of doing some math. Correct? So this is our little shoebox example where we're saying, okay, well, inside the shoebox I have a string. And I'm going to convert that string into a number. What the heck do I expect? Okay, kind of like when you put the chunk of metal into the water and tried to mix sugar into it. What are your expectations on what should go down when you try to do that? The expectations should be very low. Okay, so in any case, we need to be able to handle exceptions instead of just having our program crash like this. Program died. Okay? So what I'm going to do is I'm going to surround this with something called a try-catch. All right. And we'll just say woot in there. So we're going to try to print out integer.parseInt of s plus 1, which we know throws an exception. But instead of the program crashing, we will try to do that. When an exception occurs, or if an exception occurs, we will catch that exception into this variable called e. You can be very specific because you can have multiple catches to a single try. You might want to catch I/O exceptions. You might want to catch a number format exception. So you can be explicit so that you can do different things depending on the type of exception that occurred. In this case, I'm just capturing anything that is an exception. So exception is to exceptions as object is to all of our objects. It's the top level guy that all exceptions are part of. So by me saying catch an exception E, I'm saying anything, any class of exception, go ahead and catch it, store it in E, and I'll just deal with it. And how do I deal with it? Well, I just print out woot. Okay, which is a far better solution than printing out a real error message that tells you what went wrong. All right, so we have the same problem, but now we see that our output is woot. It's like, oh, perfectly acceptable output to our program. No error, we don't know what the heck happened, right? All right, so this would be how we would deal with things that throw exceptions. Okay, we haven't written our own exceptions yet, but this is, assuming an exception exists, this would be how we deal with it. Okay, now some exceptions we are required to deal with. Other exceptions we can choose to deal with. Okay, integer.parseInt would be one of those. It throws an exception, but we don't have to deal with it. That makes sense? And we'll look at that here in a minute. So, now, what we could do is we could say, okay, well, we'll print out woot. Well, actually, instead of that, let's do this. We'll say, oops, s was actually supposed to be equal to 5. We made a mistake. All right, and then we can go ahead and do this again, knowing it'll work this time. So, exact same error happened, but we caught the exception, changed s to 5, then did the math. Okay, there's also a finally clause we can have in here. And that's where we can finally say woot. We want this to happen at the very end. Okay? So let's go ahead and here we'll do, well, I'll run it. We should see 6 and then we should see woot, because that finally always occurs. I'm going to go ahead and set hello equal to 10. Now we should see 11, because we will not have an exception here, right? Because integer.parseInt of 10 is a real number. And we still see the woot. Okay, so finally always happens. Make sense? And then after this whole try-catch structure, we'll say I'm still alive. Run this again, except I need to spell stuff better. There's the 11 woot, I am still alive, but that's expected because an exception didn't actually occur. But now we'll change it back to hello, where we know an exception does occur, and we see that I am still alive. So our program did not crash. We handled the error in our program and decided that it was appropriate to keep going. Does that make sense? So exceptions and throwing an exception and handling exceptions are ways that we can deal with errors in our program without the program crashing. All right. It also allows us to have responses from a method that returns something like an int that is not an int. So let's look at that. Let's get rid of this stuff. Now that I think about it, I have a feeling that the reason why the GitHub was being so sluggish on Eclipse is because I had a .git directory at the top level of my Dropbox, and my Dropbox has 3 terabytes of stuff in it. Locally here, probably only has like maybe 50 gigabytes of stuff, but still, it was sluggish because it was trying to add all those things to the repository. See, I took a book out of your off your shelf there, Alex. See, Alex was doing the same thing before class. Like, why is this taking so long? Because he had it at the top level of his directory. What is my... It doesn't show me what my... Again, didn't it used to? Dropbox used to show you what your total storage is. Maybe it's just infinite now. Didn't it used to say?
Oh, it's click on the settings or the top right. No, you don't.
Oh, there you go. So 5 terabytes.
You're using
13% of it locally because I don't sync all the things. This is a solid state drive. Don't quite have the the capacity to fill it up with everything that's on there. So I think I have at least 2.5 terabytes of stuff. Okay, so what we want to do now is we want to go into our linked list class. And we're going to go to our remove front method that we wrote. And in the event that head is equal to null, if head is equal to null, we want to throw new exception say we'll just say cannot remove front empty list. All right, so we're going to throw this exception. Now what we need to do is we need to advertise this method as something that throws an exception. Okay, so now my remove front is the same as it was before, still is expected to return an integer, but I've thrown in the ability for it to throw an exception in the event that something bad happens, which means that we don't have to return an integer. So if head is equal to null, we're going to go ahead and throw an exception saying you cannot remove front from the empty list. Otherwise, we'll go and do the old stuff that we used to do. When you throw an exception, the method immediately ends. All right. So let's go back out here to driver. Let's just get rid of all this crap. Now I'm going to say system.out.println ll.remove front. Okay, so we have the empty list here. And notice, which should mean that head is equal to null, notice this guy's yelling at us because it's saying this dude throws an exception. You have to deal with it. So I'm going to say, oh, okay, this guy throws an exception, no problem. So I'm going to go ahead and we're going to do the lazy way of doing it just so we can see our error message. And that is pass the buck. So we could surround this with a try and catch just like we just did a second ago. Or we can just say, you know what? I don't want to deal with it. So I'm going to make main throw an exception. We'll just let the Java virtual machine deal with it. However it handles exceptions, which what it does is it spits them out to the screen. Okay? So I've chosen not to deal with this exception personally. Instead, I just passed it to the guy who called me, and we'll just see what he does. All right, and it's important that this thing at a method level, it is so what we're doing here, it's passing the buck. It doesn't always just pass it to main. So for instance, I throw an exception in here. That exception shows up here. I could either choose to deal with it, or I can have this guy throw that exception and let whoever's above him deal with it. And if he's not the top level, he can throw the exception and let whoever's above him deal with it. So you can choose at what level do you want to deal with these exceptions. So we'll see our exception now. I'll go ahead and run it. I'm trying to remove the front. So notice this looks like a completely legit error message, but it's our message, cannot remove front empty list. Okay, so we were able to throw an exception without returning an integer. Make sense? All right, so what we can do now is we can say we're going to try to do that. We will catch exception. We should probably do something, but it's not uncommon to just do nothing other than not make your program crash. So maybe we say system.out.println failed to remove. So in a graphical user interface type program, you might give a little pop-up saying, I couldn't accomplish what you wanted me to accomplish. Hit OK to continue, that type of stuff, instead of the program just shutting down. So fail to remove. Then we'll say add front to, let's just add. So this is list 765432. And then we will say try. Oh, here, let's just steal this. So now we'll try to remove from the front, which should remove the 7, which was the last thing we had. It'll print out a 7. Right before we do that, we'll go ahead and say ll.display, showing us the full list. And then right afterwards, we'll say ll.display, showing us the list after we've removed it, seeing that the 7 has been permanently removed from the list. Make sense? All right, so we'll go ahead and run this. There's our fail to remove, our first try catch. Then here's our list, 765432. Then we remove the front, there's our 7. Then we see the resulting list, 65432. Make sense? All right, so exceptions are how we can handle errors in the event that we cannot return a value of a certain type. And this comes in most handy when we're dealing with integers. We're returning something before, before exceptions, you would have to come up with error codes that meant something. And these error codes would have to be something that wasn't legitimate output from your program. So if I'm doing some math, it's entirely possible my answer could be -1. So we can't just return -1 in the event of it being bad, something bad happened. Return -1. We really want there to be an error. Does that make sense? So that we can handle it. So that's where the exception handling stuff comes in. All right, so let's go ahead and do remove end. Public int remove end. We'll say this guy also throws an exception. If head is equal to null, meaning we have the empty list, we'll go ahead and steal this line here, which is to throw a new exception, cannot remove end. From the empty list. All right. Otherwise, now notice I don't have to do anything special to make this stuff happen anyways. when we throw an exception, just like a return statement, throw immediately makes a method end. Immediately. Okay? So I won't continue on with the rest of the code. So if I'm still kicking right here, that means I didn't hit the exception. And we're good to go. We have at least one node. So what do I need to do? Back to our picture. I need to traverse all the way to the end of the list. Okay, all the way to the end of the list. So if I do that, I use cur. So I'm going to traverse all the way to the end of the list. Let's say I'm pointing right there. This is the guy I want to remove, right? Well, now we have an issue. If I'm pointing at that guy, how do I remove him from the list? Set his next pointer to null?
Set the previous node's
Oh, we need to disconnect this previous guy's pointer. Well, how do I get to him?
His next
one. Using the index.
one. Oh,
and
to
do-
that one. Get the one before.
Yeah.
Say this again.
Count minus one.
Okay, we could take advantage of our count, right? Take advantage of our count. What if we have a one list? So if we have a count of one, and I'm right here, head points to the one thing. So this is our, in that example, this is our entire list right here. And I want to remove from the end. The end and the front are the same, correct? So what am I going to do with cur? Go ahead.
Should we, in remove front, should we change count down to 1? Or
Oh, definitely. Definitely. Good thinking. So remove front only if we actually remove something. We want to set this dot count minus minus because we're keeping track of our count at a global level. So if I'm down here, that means I indeed remove something from this list. So if I remove something from the list now has one less thing than it used to have in it. So we need to make sure we decrement count. Good catch. So in the event of a one list, can we go to count minus 1? As he suggested? Oh, would it? This is the one list.
Count is 1 minus 1 is 0, so it takes 0.
Okay, so now what do? I'm at 0.
Get the
There's nothing here. So you start cur off at head. Then we're going to have a for loop. So cur points right here. So for int I is equal to 0, I is less than count. Count is 1. I plus plus. But you want to go to count minus 1, right? So for I equals 0, I is less than count minus 1, which is then 0. Is 0 less than 0? It's not. 0 is not less than 0, so we'll stop. Cur currently points to the node we want to remove. Now what do? How do I get rid of this guy? Go ahead.
You just call your remove front.
In this case, remove front would be fine, right? Because remove front, what does it do? It's going to set cur equal to head, and it's going to do what? Set head equal to cur's next node, which is null. Does that make sense? So in the event of a one list, we could call remove front. That would be legit. So we're right here. We're saying if head is equal to null, cannot remove from the empty list. If, well here, let's do else if, this dot count is equal to 1. If we have the one list, then we'll go ahead and return this dot remove front. Make sense? Go ahead.
You just did that. Remove front.
Oh, I did. Thank you. I put this in the wrong method. All right, so else if count is equal to 1, return remove front. Otherwise, we're still kicking. And we could throw it in an else if we want. Won't make any difference. So if you want to structurally do that, it makes plenty of sense. Otherwise, you want to actually do the logic. You want to actually do the logic to remove from the end, which means we need to go to count -1 and then hook stuff up. Okay? So for your homework, finish this. So finish writing remove end and write remove at index. Submit the code to GitHub. Okay, and I'll give you this code as a starting point. And I'll see everybody on Thursday.